So while this is getting set up, I'll just introduce myself. I'm Scott Emery. I work at Cumulus Networks, and I'm the networking project co-lead at OCP. And I've had a cold for the last couple days, and so I'm going to let Wataru do most of the talking here today.
Yeah, I can only, I don't know how to copy the
Yeah.
display.
Look there, I'll do
Yeah.
advance.
Okay, so we'll talk about the TAI, Transponder Abstraction Interface. First of all, I want to describe the problem we are having. So SAI solved the issue of the abstracting the Ethernet ASIC. So we are having the similar problem with the emerging open optical transponder. I will describe what it is later, but first of all, the problem we are now having is optical transceivers, which enable the transmission over the, for example, 80 kilometers or sometimes 1,000 kilometers. These open optical transceivers are really complex, like Ethernet ASICs, and expensive part of the optical system. So there's tons of registers in these transceivers, and most have SDKs which needs NDAs to use, and each have the different interfaces. So this is really a similar situation in the Ethernet ASIC. So and optical transceivers vendors invest a lot of money to develop their transceivers, want to maximize their invest, of course. And the system vendors who utilize these transceivers also invest a lot, and they want to use transceivers from multiple vendors, not only the bind to one vendors. So the open optical packet transponder system have created this opportunity for the component and system vendors to work with larger open ecosystem. Okay, so what is open optical packet transponder? So this is one example, the Voyager, which is announced by Facebook, I think 2 years ago. Yeah, so this box is a 1RU box, which has a Tomahawk inside it, 12 client port, 100 gig QSFP28 port, and 4 line ports, which goes to the other end of the site. So this can transmit over 100 kilometers. So inside the box, other than Tomahawk, there is the optical transceivers. As for Voyager, it comes from the vendor called Acacia. Yes, so it's really similar to the white box switches, which SONiC supports. But in addition to those components inside the white box switches, this Voyager had the optical transceivers, the DSPs and optical transceivers in it. And another example is Cassini from EdgeCore. I believe you can see the actual running Cassini in the Expo area in this OCP Summit. This has a Tomahawk Plus ASIC in it, 16 client ports, and 8 swappable modules for the line side. There is several types of line ports. So one is CFP to ACO type. This is CFP to ACO is the name of the form factor, the transceiver. And there's also CFP to DCO type modules. So you can choose what you want to use and insert it to these 8 slots and use it for the longer transmission. So other components is really similar to the Voyager. Okay, so we have this kind of troubles. So and Scott was working working in TIP, Telecom Infra Project, a similar organization like OCP. So in there, we are trying to promote this kind of open packet transponders, and we hit the trouble I mentioned, and we come up with the TAI. So this problem in the white box switches, this is solved by the SAI. I think I don't need to repeat this slide because I'm pretty sure you are the developer of SAI. So yeah, so we took most of the part from OCP SAI and revealed it in TAI. Yep, I think I can copy it, skip it, sorry.
Okay.
Yep, so SAI becomes a TAI, Transponder Abstraction Interface. So it is a collection of C header files like SAI. And the implementation, C shared library, libtai.so, will be provided by each component vendors. So yeah, now provide a common interface to optical modules. libti.so is a binary blob, so you don't need NDA. You can get it from the vendors and use it without NDAs. Current version, it is also already open source. So if you go to the TIP's GitHub site, you can see what is in there. And it's already used in the production NOS. So Cumulus, which support Voyager, is using TAI inside their NOS. And IP Infusion, which support Cassini, they're also using TAI in their NOS. And my plan is put the TAI also into SONiC. So hopefully I want to have a SONiC support in Voyager and Cassini and add this TAI functionality into SONiC. Okay. So this is a little bit detailed explanation of TAI. I think most of you can already know about this. So with using the TAI interfaces, you can mix and match the lower layer vendors and the upper layer applications. Okay, next. And what is not TAI? So I'm also sure you already know this, but TAI is not a young model or other northbound APIs. So many times people misunderstand why you start another the new open API things. So we already have open config, TAPI, or other open APIs. So we always use this slide. So TAI is not about that. So TAI sit below those northbound APIs. Okay, and here's the difference between SAI and TAI. So transponders, open transponders are commonly modular. So but the switching ASIC inside the white box switch is only one and fixed. So we have to handle this modularity in TAI. So we added some callback functions, some functionality inside TAI to support this modular characteristic in the open transponder. Yeah, and also, so for example, in Cassini, since there is 8 module slot, we can, for example, use 4 slots for CFP to ACO and 4 slots for CFP to DCO. So we can mix several types of the module inside one system. So, but from the upper interfaces, the application only want to see the one TAI interface. So to support this, we added kind of multiplexer layer inside TAI to support this kind of heterogeneous environment in the transponder. Okay, so this is a history of TAI. It's almost a one-year project from the beginning. So first, NTT, I submitted the initial specification and POC implementation of TAI. And then Cumulus, Scott, refactored many things to make it really work. And they also ported that to Voyager. And then Edgecock comes in with Cassini. Also Lumentum. Lumentum is a transceiver vendors. They also joined to add more enhanced feature inside TAI. And then IP Infusion, the NOS vendors also another NOS vendor joined to make it more useful. Okay. Yep. So now supported with these companies. So we welcome more contributor and hope TAI can become more active, and finally also we want to put the TAI into SONiC someday. Okay. Yeah, last slide. What next? Yeah, we will put more features to exploit the hardware capability. So these optical transceivers have many functions, like switch ASIC. So we will continuously add more features into TAI, and more features to ease transponder software development. So like PTF, we are also planning to add these kind of the continuous integration mechanism inside TAI. We also have a meta library like SAI. And also we have the utility tools called the TAI shell for the easy development. So we will continue to add these kind of user-friendly features. Yep. Okay, that's all from me.
One of the overarching things I wanted to get across today was first to say thank you for developing SAI, because it basically reduced our work quite tremendously to be able to have that as a basis for developing TAI. And also to let you know that what is being done with SAI and SONiC is much more far-reaching than what you probably are focused on. And these technologies, like in this case, are being employed in systems and in ways that are far beyond what just the switching group that you've been focusing on. So, thanks. So we have time for questions.
Yeah, thank you. Just real quick, to clarify, in a system like Voyager running SONiC, SAI and TAI would run side by side, is that correct? You'd have both in there?
Yes, both SAI and TAI, yep.
Okay, thank you.
Yeah, there's nothing that prevents them from, the SAI would access the switch ASIC and the TAI would access the transponders. And there's no conflict, and they just have two interfaces from SONiC down. Well, one would be for the switches and one would be for the transponders.
So in a system like SONiC, we have a shared library for each ASIC vendor, right? So when we have a Broadcom ASIC, we have a SAI implementation from that vendor. In the case of TAI, we could have multiple, as you say, transceivers are modular, so we can have multiple, optical vendors. So we'll have to have, in a system like SONiC, we would have to have multiple shared libraries, one per optical vendor. Is that correct?
Yes, correct.
And what is the vendor support looking like right now? How many vendors have adopted TAI?
3.
3 so far?
Yep.
Is there more interest, or is there, are we looking to push this out
I
further?
hope so, yeah.
Great, thank you.
Yeah. You might want to talk about the MUX.
Yeah.
Okay, so that's one of the differences between SAI and TAI is that, like we said, with SAI there's pretty much one switch ASIC. I don't know of any system that has multiple switch ASICs or multiple switch ASICs from different vendors. I mean, that's absolutely unheard of. And so we developed what we call a TAI MUX. And what the MUX does is upwards it prevents a single interface, but down below it can link to multiple shared libraries. And so it can detect the type of transponder that is inserted and use the library, connect that one up to that transponder. And then if there's a different one, it'll load a different shared library and link that one in. Any other questions?
So I saw there is a tie shell, because since TI and the SAI, it's very same, right? So I think maybe the tie shell can also be extended to cover the SAI shell. Is there something that is doable?
Yep, yep. So I was also thinking the same thing. First, the TI shell is heavily using the meta library. So I'm wondering if we can use the same meta library both for SAI and TAI. So first I tried to revalidate the SAI meta library for the TAI, so use the same code base, but it was too kind of binded to SAI. The SAI meta library is too binded to SAI header files. And also, I'm not good at writing PAL. So I gave up using SAI meta library and build from scratch. But yeah, if we can use the same meta library, create the same, how can I say, generate the same meta header files and meta source code,
Okay.
I think it is possible to use a TAI shell for both for TAI.
So the shell is available in the website. Yeah, okay. So I think we can take this offline.
Yep, yep.
Yeah, so for those that aren't familiar with the shell, it's basically a command line interface used mainly for debugging that inserts itself in the TAI layer so that you could issue commands and get status and so forth of the underlying hardware. So something like that could be added to SAI to do some debugging. If you want to get some attributes or set some attributes just on the fly, you could do that with the TAI shell or SAI shell. Any other questions? Okay, thank you.